Hey, Mr. Derry here, guys. I'm in Canvas, and first off, I want to apologize for the delay with this week's lessons. The good news is I cut out part of what was required. So if you look at this sheet right here, we are going to hold off on the wheel and axle part. So I'm going to bump that off till next week. So it's taking a second to load. Calculating mechanical advantage wheel and axle, don't need to do it. Calculating mechanical advantage brake lever, that's what I'm going to show you right now. Alright, so going back into the modules here, I have not posted this yet, but this is what you're going to be doing. The video that we're recording right now is going to be in the watch this first. So please watch this first. When you go in here, after watching this video, there is another video on, it's going to explain how to calculate mechanical advantages with using levers. This guy's moves a little bit slowly, so if you do want to watch this video, I suggest watching it at double speed. What I want you to do is take a photo of your brake lever and the rear brake. Okay, so what I've done here is loaded an image of my brake. Notice that this point right here, hopefully you're recognizing that as the fulcrum. This is my input distance. Alright, this is my output distance because that's where the cable attaches. I want you to measure that line, not this line, because really here's the distance from the fulcrum. That's where our advantage comes in. And then I want you to measure this line. Okay, that's our output distance, and it's really going to be the distance that the cable moves. But we'll talk more about that a little bit later on. So to calculate the mechanical advantage at the brake lever, what you're going to do is, and this is called ideal mechanical advantage. There are some losses. We'll talk more about that later on. So the blue line up here is my input. The red line is my output. So I simply divide my input by my output, and I get my mechanical advantage. This line is longer than 2, but let's just say it was 2 divided by 1, 2 times my mechanical advantage. Alright, that's great, but to get the mechanical advantage at the actual brake pad, we need to do more calculating. So here, and I'd like you to do this, take a picture of your rear brake. By the way, if you don't have a bike or you can't find your own, go online. There are tons of pictures of brakes, and just look these up. Rear brake, brake levers, you'll find some images. Below is the rear brake, and hopefully you're recognizing this as a class 2 lever. Here's my fulcrum, here's my load. The load is the brake pad pushing back on this lever, and here's my input force, which is the cable moving at this distance out here from my fulcrum. So, estimating purposes, let's call this one 3 to 1. Alright, so same formula applies. My input is 3, my output is 1. I divide these two, I have a mechanical advantage of 3. To calculate the overall mechanical advantage, we're going to take the mechanical advantage from our first problem, multiply it by our second problem. In my case, quick estimations, I don't have a tape measure on here or a ruler. We're talking about let's say it's more like 2.5 or almost 3 to 1 here, but I called it 2. This one we'll call 3. Alright, 2 times 3 is 6 times the force. So if this, I'd like you to do your own, show me the numbers that you have. If you pull on the brake lever with 10 pounds of force, I want you to tell me what the force is at the actual brake pad. Alright, and I think you're going to find that it's a pretty impressive number. Alright, hopefully that covers it.